let's talk about the objectives. Okay, so first of all, we are going to find and interpret the standardized score of an individual value with this distribution of data. And then we're going to go back to old school and look what happens to the effect when we add, subtract, or multiply or divide a constant by a given one. And yes, we are also going to be estimating the location of the median and the mean in the density curve. Okay, now, I just want to remind ourselves or go over this really quickly, the idea of what you guys did on, what I did on the previous video from last night, density curve. Okay, when it comes to the density curve, specifically the one that I'm really the most concerned about is z-score. Our statistical analysis, when we are doing hypothesis tests, etc., and when we're finding probability, we are always looking at the z-score. And here, as I just remind ourselves of what was on that last video, we referred to the z-score also as the standard score. And the reason we refer to it as the standard score is because what we like to do is standardize the data. The best example that I can give you guys is something that's very applicable to you guys right now, which is the idea of your ACT versus your SAT scores. Okay, on the last video I totally bit it because I didn't know the new SATs had another numerical change. They got to stop doing that. But I was even wrong with those numbers, so, but I already said that I knew it. Okay, now, as I look at this right here, I was told by prior classes, so if it's wrong, it ain't on me anymore, okay, that the ACT max is 3,600 and the SAT max was 1,600, okay? So do we all agree? Yes, no? Yes? Afraid to be on video, people? Come on. It's okay. Okay, now, so what I did here is I had someone in third period Google. She was interested in Cal State Fullerton. And let's say when she found out the SAT average for admittance at Cal State Fullerton was 1,080, but for the ACT average was 21. Now, these two standard deviations are 100% wrong. And the reason they're 100% wrong is because they don't give that statistical data, because even if they did, no one would know what the heck it is. So it's like, why give it? You know, why confuse people even more? Okay, so what I did was use these numbers. And as I use these numbers, my question is, how do I know if this person, which score should we submit? So let's say that Sam, and as I looked at Sam's score for his SAT was 1,300. Now, but Sam's score for his ACT is 26. And Sam's trying to figure out which is the better of the two to submit. Okay? So that means we have to do what we've been talking about right here. We have to standardize it. Whenever you see on a test, which you will, and I say, what's the standard score? That's the same as saying, what's the z-score? So make sure you know the language. But I'm going to take this and standardize it. Because in our world, there's a huge difference between a 4-digit number and a 2-digit number. And our question is, how do we equate the two? Well, if they're not nice enough to give us our percentiles, we're stuck. Nope, no, we're not. We can find the z-score value. So here, the formula for the z-score, okay, we know is what? Minus what over what?
X minus the mean.
Okay, x minus the mean over standard deviation. So what I want to do right now is I want to find his z-score for his SAT and his z-score for the ACT. Okay, go ahead, ladies and gentlemen, go for it. Do the math. Okay, so what is his standardized score for the SAT? 1 point what?
375.
Okay, 375. And what about for his ACT? 1.43 something? Okay, okay, approximately. Okay, so with that being said, the bottom line is in both situations, he is above their average. Okay, but you know as well as I do, when we apply to the college, we want our strongest score. Now, as we look at our strongest score, here did better on the ACT than he did on the SAT, because this is farther away from the mean in a positive direction. Or mathematically speaking, this is bigger than that. And let me show you what I mean when I say farther away from the mean in a positive direction. Okay, as we look at this right here, looking at your homework sheet. This, I'm going to have to stick it up here because it's too crowded. Normally I put it down there. But that is our mean, straight down in the middle. I would highlight it, but to no avail because orange on black. Yeah, anyway. Okay. Okay, now, as I look at this right here, there's your mean. So here is one standard deviation below the mean, one standard deviation above the mean. This is the middle 68% of the population. Here is two standard deviations below, two standard deviations above. That is the middle 95%. I don't want you to think that's a dot right there. Okay, and that's where quality control is always utilized. If it's above it, it's too much. If it's below it, it's too little. Lose customer satisfaction on if it's below. Here, they lose money if it's above. So the middle 95% is what companies always attain for. Okay, next, going back to this idea, 3 standard deviations within the mean. So this is 99.7%. So now, as I look at this right here, and I found this, how the bell curve works, people that are over here are the Bill Gates, the Oprahs. Who else is a billionaire and basically have nothing to do with their money? No, she's Whoopi's not here. Whoopi Goldberg's not here. Huh? Jennifer Aniston is not here either. Okay. Warren Buffett, there you go. Yeah, he's probably over here somewhere. Okay, now, as we look at this, this is the thing. Okay, you can see what's left over is 0.3%. That's what's left over here and what's left over here. So half of 0.3% would be the people that are over here. Okay, we always like to, okay, I put a me here, but none of us in here are even close to that. And I've been teaching for 30 years, and seriously, I've only had 1 or 2 students that have been there. Because those are those students that applied to MIT, Harvard, Yale, Stanford, and got to choose which ones they could go to. And got money for it. You are there, you know. And when I say that in this class, none of us are in here, I'm not saying that to be mean or condescending. I'm saying that you guys are brilliant, but not quite. But I could easily say in this class that you guys are definitely about here, okay? Because you are higher, you are that 2.5%, that upper 2.5%, and I could say that with a lot of confidence. So now we can see how in that situation before, he had a 1.4, that was slightly above the 1.3. He's closer to extreme excellence. That's a better way of putting it. Okay, but at the same time, as we look at this end right here, that would be a very impoverished person, a person that is so poor that they literally don't have anything. They don't have a home, they don't have a car, because you know some people sleep in their cars. That would be the lower part of our socioeconomic base, which should not exist, but that's my political issue. Okay? Okay, so let's talk about the next objective. the density curve and the normal distribution. See, this is the thing. When I hear density curve, I think of it as a curve. But a density curve is not always a curve. It can be like this, or it could be a rectangle. But the one thing that it does have to have, I should say the two things. It has to have a horizontal axis, okay? So it has to lay on its axis. It can't be like a diamond type thing that's sitting on its, it can't be this, like that. It cannot be that, okay? So it has to have a horizontal axis that it sits on, and this is the most important aspect. The area under the curve is always equal to 1. Now, this one, I meant to have two different ones, but obviously I didn't. I cut and pasted double vision. Sorry for those of you who have eye problems. Anyway, okay, as I look at this right here, I just wanted to remind you because I know some of you guys have had Z-score before, but see, the beauty of the Z-score is it gives you probability. I don't know if you remember, but some problems that you guys had in Math 3 or even pre-calculus, the probability problems were horrific because you didn't know what to do when. You didn't know what to do in certain situations. But if you could standardize things and put them into a Z-score, there's a table that you guys are going to get tomorrow that'll help us to find the area under the curve. So for this one, here we're talking about scores on a vocabulary test. So as I look at this, basically it's saying the area under this curve is 33%, which we'll learn how to do both on a table and on the calculator. So it's saying that 30% of the students approximately got less than 6 on this vocabulary test, or the vocabulary score. So that's what this represents. And like I said, this is nothing but a duplicate. Okay? Now, let's continue. The ideas of symmetry, you already know this. So I'll give you a couple seconds to write it down. So as I was saying, this is nothing new. We've said this before. But let's go to these drawings right here. And I will give you a minute to write things down. And yeah, I crossed out the middle one. I'll clarify in a minute. Now we're about to apply all of this information right here. But the bottom line here is that, remember, we've already talked about this, okay? When we have the majority of the data on the left, it is right skewed, you've got more observations. More data, more observations, it's the same, just slightly different language. Here, when it is left skewed, more observations are on the right. And when it's symmetric, the observations are equally dispersed. Now, before we get into examples with that, let's finish up the notes. A uniform distribution. So, first of all, a uniform distribution looks like a triangle. Okay? Or not a triangle, a rectangle or a square. Rectangle or square. And as you look at this right here, that means that the probability of occurrence is equal. So I have the days of a week because you've got 7 days a week, and what's the chances of you choosing a particular day? Well, you've got 1 out of 7. It is equal distribution. I need to cap this off. That's not bad for me. Okay? And another example of this would be a dice. Because what is the probability of choosing a number 1 on a dice? 1 out of 6. What's the probability of choosing a 4 on a dice? 1 out of 6. That is another example of a uniform distribution, so make sure you've made a note of that. Okay, so I'll stop so that you can write down what you need to write down. So as you mentioned, the probability of choosing a day of the week is 1 out of 7. And if you're wondering what the point is of this, is that this is a way for us to verify that this is a density curve. Because we established the area under the curve is equal to 1. Well, if there's 7 days a week, that means in order for it to equal to 1, that means we have literally 7x is going to equal 1. Well, what does x have to equal 1/7? If you notice there, I already had it written down for you, but the reality is if it is a rectangle or a square, you can easily solve for the height with the understanding that you've got the length of the horizontal. Something that's really important before we jump into our examples is the idea here, uniform distribution is a type of non-normal distribution. So first of all, a normal distribution is a bell curve. That's a normal distribution. So a non-normal is a uniform distribution. We're gonna have a lot of different skews. Ones in the future we've seen skews. Let's look at this one, jacked up one. That's still a distribution. It's not a uniform, but it is a non-normal distribution. What I have going on there. But the thing here, as we look at this language, the square one comes from a family of ones that don't look curvature like this. That's how the language reads. Okay, now let's go ahead and read number 36 and answer that question. They asked us to explain why this curve satisfies the two requirements. Okay, so as I look at the first requirement that really no one pays attention to, but again, it can't just be sitting on like that. Remember, that's the okay. Here it is laying on the horizontal, so that's check. And what is 10 times 1/10, guys? It's 1. 10, really? Okay, it's 1. So yes, we have confirmed that yes, it does satisfy the requirement. Now we can go ahead and go to the next page. And I don't know if you want to put it in a situation that you can see both at the same time. Good luck with that. Okay, so with the curve that we had, we want it to be more than 8 minutes for the bus. Okay, so ladies and gentlemen, go ahead and find for me what the probability of it being more than 8 minutes. Okay, what's my answer? What's my answer, guys? 20%. You guys are like, was it? I know your thoughts are, Yarbrough, is it that easy? I don't understand. Yeah, this is all it is. If from here to here it's 80%, here from 8 rather minutes, from here to here is 10. Well, we know the total area under the curve. And for those of you who are thinking, I didn't do all that, Yarbrough, this is what happened last period. I didn't pay attention to the more than, and I had 80%. It's like, wait a minute, Yarbrough. I'm like, oopsie. Because the reality is all you got to do is subtract 10 from 8 to get 2. The distance from here to here is 2 times 1/10. Take yourself back to elementary school when you were first taught how to multiply. I do this to my Math 1 kids all the time. I say 8 and x. What do I say? 8x. It's the same idea. You guys are going 2 times 1/10. With that being said, go ahead and find for me the answer for letter C. What you guys get? 28%? Yeah. And you know what you had to do? Just subtract the 2 from each other and subtract it from the height. Okay, now let's go ahead and read number 39. And as we read 39, let's see how we can determine which is the mean versus the median. So again, as we look at this, are you noticing that the left side equals the right? So with that being said, what is the mean and the median for this problem? B. Because remember, whenever the mean equals the median, they are symmetric. Now, what about this one right here? How do we figure that one out? Well, isn't that a big hint right there? Like you said, like I'm hearing Shane say, it is right skewed. And if it's right skewed, that means, okay, so to clarify, 10%. To clarify here, this is your mode because it's the tallest. This right here is your mean because it's bigger than that median right there. Okay? So, I want you guys to go ahead and do number 40. Okay, so we're ready to see our answers? Any questions? And I know they didn't ask for the mode, which is what I whited out, so I need to put it there. But even though they didn't, it could be a multiple choice question waiting to happen on a quiz test or an AP test. Okay, so you've got your homework, and I will see you guys tomorrow. Have a good evening.